The shear force and bending moment diagram for a cantilever beam carrying one of the point load at the free end. Okay, so what is mean by actually cantilever beam? Okay, so if one end of the beam is fixed and if other end of the beam is free, so that type of beam we call it as a cantilever beam. Okay, so this is one of the cantilever beam. Okay, so let assume it is A and B. Okay, so at this end, at one end, okay, at A, okay, so this end is fixed and this other end is free. Okay, so it is carrying one of the point load at the free end. Okay, so we have to draw the shear force and bending moment diagrams. Okay, so according to the fundamental principles, okay, so we know how to draw the shear force and bending moments, okay, diagrams. Okay, so first before going to draw the shear force and bending moment diagrams, okay, so first we have to determine shear force and bending moment at each of the different cross sections. Okay, so according to those values, okay, so we can draw the shear force and bending moment diagrams. Okay, so let me calculate the shear force and bending moment at different sections of that overall length of the beam. Okay, so then after I will draw the shear force and bending moment diagrams. Okay, so what is meant by actually shear force and bending moment diagram? So shear force diagram is one of the diagram, okay, which shows the variation of the shear force along the length of the beam. Okay, so now what is meant by bending moment diagram? Bending moment diagram is nothing but it is the diagram which shows the variation of the bending moment along the length of the beam. Okay, so assume here this L is the length of the beam. Okay, so capital L. So let me determine the shear force and bending moment diagrams. Okay, so this is one of the cantilever beam. Okay, so and I am taking one of the cross section here at a distance of x from B. Okay, so from B I am taking one of the cross section xx at a distance of x from B. Okay, so let xx is the cross section at a distance x from B. Okay, so now let me define what is the shear force and bending moment at that cross section xx at a distance of small x from B. Okay, so now let me write the shear force. Okay, so shear force at x. Okay, so shear force at a distance x from B. Okay, so what is meant by actually shear force at some one cross section? Okay, so shear force is nothing but what? It is the algebraic sum of the all vertical forces to the right of the section or left of the section. Okay, so if we take one of the cross section, okay, so by adding algebraic sum of all vertical forces to the right of the section or left of the section, if we do, then we get the shear force at that cross section. Okay, so I am taking one of the cross section xx at a distance of x. Okay, so I am going to determine the shear force at a distance of small x. Okay, so then f suffix x, that is nothing but shear force at x. F suffix x means this is the shear force at a distance x. Okay, so like if I write, okay, what is the algebraic sum of all the forces to the right of the section? I am taking one of the right of the section. Okay, from this xx cross section to right side portion I am taking. Okay, if I take, so what are all the vertical forces are acting right of the section? Only one force is there, that is the point load at the free end. Okay, so that and that sign convention. Okay, so what is the total load algebraic sum of all the forces? It is W. Okay, so after determining the algebraic sum of all vertical forces, then we have to determine the, okay, so here only we are having only one force. If any other force is there, that one also you have to add. And if the force acts downward, okay, so that you have to take positive, and if the force acts upward, that you have to take negative. Okay, so when we choose right of the cross section. Okay, so this is the one of the force W, it is acting downward. Okay, so definitely we have to take it as a positive, right? Okay, so shear force at x. Okay, so it is the algebraic sum of all the forces to the right of the section. What are the forces we are having right of the section? Only one force is there, that is W. Okay, so here algebraic sum of all the forces will be equal to W, and that is acting downward. That's the reason you have to take it as positive. Okay, so actually if it is positive, okay, we no need to mention here positive symbol. Okay, so if it is negative, then definitely you have to indicate with minus. Okay, so here this is the positive. Okay, so this is the shear force at a distance of small x from B. Okay, so then now this is a general equation. Okay, so this is the shear force at x, indicating that it depends on what? It is the W only. Okay, so this is not dependent on the variation of the x. Okay, so if you take cross section somewhere here also, you will get a shear force that W only. So even if you take anywhere, okay, so you will get the shear force W only. What is the meaning of that one? Here x term is not there. Okay, means what? That it is not dependent on x. Okay, so it is the independent of x. Okay, so that is the reason. So we can say that, so this shear force is constant from B to A. Okay, so if, this is the shear force. Okay, so next let me write one equation for the bending moment. Okay, so I am in the shortcut, I am writing bending moment okay at x. Okay, so bending moment we indicate with m, and that bending moment at x will be equal to m suffix x. It should be equal to, okay, so what is the bending moment here? What is mean actually bending moment? Bending moment is nothing but what? It is the algebraic sum of all the moments to the right of the section or left of the section. Okay, so due to all the forces. Okay, so here what are the force we are having? W is there, and if I take the right portion of the cross section, then okay, moment due to only this downward force only. Okay, so that downward force is the moment is nothing but what? Force into distance, right? Okay, so W is the force acting, and that is the point load we indicate with capital W. And what is the distance, perpendicular distance from load to this cross section? Okay, so that is the x. Okay, so W into x will give the bending moment at cross section. Now we have to apply the sign convention. Okay, so if it is if it gives sagging moment, okay, we have to take it as a negative, and if it okay, moment due to load or force, if it is a sagging, if it gives sagging moment, then we have to take it as a positive. Okay, so due to this downward force, okay, so how this beam bend like this, right? Okay, so it is a sagging moment, so that is the reason we have to take it as a negative. Okay, so sign convention, it will be, if you apply the sign convention, it will be negative bending moment. Okay, so from this expression we can know clearly that, okay, so m suffix x equal to minus W into x. Okay, so here x is the variable, and that this bending moment depends on what? Okay, so value of x. Okay, so as the x value increases from B to A, okay, so this bending moment also get increases, isn't it? X is this W is constant, and x is variable. Okay, so if you take cross section here, x value will be more than this x, right? Isn't it? Okay, so as the x increases, then what will happen? The bending moment gradually increases. Okay, so here x power 1 is there. Okay, so if the x power 1 is there, okay, so that indicates that, okay, so it is the variation of the bending moment from B to A with increase of x. Okay, so it will be linear. Okay, so if x power 1 is there, it is linear, and x power 2 is there parabolic, and x power 3 is there cubic parabola. Okay, so and x power is 0, it will be constant. Okay, so here shear force is here x power 0, right? We can write also. Okay, so that is x power 0 means it is 1. Okay, so that is no need to write. Okay, so otherwise you can write also. Okay, so here x power 1 is that linear variation of the bending moment will be there. And okay, so now what is the bending moment at B? Okay, so from the general equation, okay, so the variation of the x, we can determine the bending moment at B as well as bending moment at A also. Okay, so if I write bending moment at B, what will be the x value equal to 0? Okay, so if you substitute x value equal to 0 in this expression, then you will get the bending moment at B, that is m suffix B means bending moment at B should be equal to minus W into 0. So you will get 0 into something, you will get 0. Okay, so this is a bending moment at B. Okay, so if I write a bending moment at A, what will be the x value? X value will be equal to L. Okay, so as we increase the x value from B to A, okay, so this A to A, what is the value of x? X will be equal to L. Okay, so that is the reason we substitute x equal to L in this expression, then you will get bending moment at A. Okay, so now bending moment at A means m suffix A, it should be equal to minus double E into, in place of x we substitute L, then you will get minus double A into L. This one will give the bending moment at A. Okay, so these are the values. Okay, so now according to these values, okay, so we can draw the shear force and bending moment diagrams. Okay, so we take the cantilever beam and carrying one of the point load W, right, isn't it? Okay, so this is the overall length of the cantilever beam. Okay, so now this is okay, so to draw the shear force and bending moment diagrams, okay, we have to take baseline. Okay, so if you get positive values, you have to draw the above the baseline. If you get negative values, you have to draw the below the baseline. Okay, so this is one of the baseline we are getting. Okay, so what is the shear force at B and at A? Okay, so it is constant, right? Okay, so shear force at every cross section, it will be constant. Okay, so it is independent of x. Okay, so that is the reason. Okay, what is the shear force at okay, at B? Okay, so it will be W. Okay, so and it will be constant up to A. Okay, so this rectangle will give the, okay, so for this beam, okay, so shear force diagram is rectangular. Okay, so because it is constant from B to A, okay, it is positive. Okay, so now okay, so it is better to extend these lines. Okay, so next I am taking one more baseline to draw the bending moment diagram. Okay, so what is the bending moment at B? It is bending moment at B is 0. Okay, so this is B, right, and this is A, and okay, so at this B, what is the bending moment? It is 0. Means what? It is in the, we have mark here the on the line, on the baseline. Okay, so what is the bending moment at A? Minus double E into L. Minus double E means we have to draw the below baseline, right? Okay, so this is the, okay, so below means no need to mention that negative. Below means it is indicates negative. Double E into L will give the bending moment. Okay, so now if I join, okay, so this is the magnitude of the bending moment at A and this is the magnitude of bending moment at B. Okay, so either way, here this is one of the very important point. Okay, so whether we should join these two points with straight line or parabolic curve or cubic parabola or constant, okay, constant we can write, okay, because some slope will be there. Okay, so here what we got here in general equation, minus double into x power 1 is there. 1 is means if x power 1 is there, it is linear variation, right? Linear variation of the bending moment. Okay, so if we join these 2 points, then it indicates the variation of the bending moment from B to A. Okay, so this is the bending moment diagram for given cantilever beam carrying point load at the free end. Okay, so this is the shear force and bending moment diagram for this particular beam. Okay, so in this way you have to draw the SFD and BMD. Okay, in short form we call it as SFD and BMD. Okay, so this is the solution for this problem. Okay, thank you.